Hello, good morning. Now today the topic is electrostatic potential. Okay, before going to the topics, let us revise. Okay, in our previous class, what we have studied? We have studied electrostatic force and then electric field, right? E. So what is F? F is, or this is also called Coulomb force. Okay, COL Coulomb force. So this F is given by F equal to 1 by 4 pi E naught Q1 Q2 by R square. Means, so this is the force between these two charges Q1 and Q2 separated by a distance R. That is, in diagram you can write like this. Suppose here Q1 is there and here Q2 is there. This distance from Q1 to Q2 is R. Nah? So the force between these two charges is given by F. Next is, what is electric field? E is 1 by 4 pi E naught Q by R square. So that means if there is one charge Q, here this is a charge, that means around this charge there is some field, right? Electric field. Here also there is electric field, and due to this charge also there will be electric field. Okay, so we want to find what is the electric field at any point around this charge. Okay, let's say point A. This is point A at a distance R. Okay, in order to find electric field here, we have to place what? Q naught here, right? So the electric field at point A is given by this formula. Okay, now today we will study what is electrostatic potential V. Okay, this formula you have to memorize. Okay, now in order to understand what is electrostatic potential at any point, first we have to understand what is electrostatic potential difference. Electrostatic potential difference. Okay, since there is difference, means there must be two potential, right? And the two potential, the difference of the two potential is called electrostatic potential difference. Suppose any point, consider any point, point A, point B. Okay, let's suppose here the potential is VA and here it is VB. So electrostatic potential difference means difference of these two, right? These two potential. So VA minus VB. So this is electrostatic potential difference. Okay, so it is defined as the work done in moving. Okay, let's say here there is charge at point A and here test charge is at point B. Okay, charge or potential at point A is VA, potential at point B is VB, and charge is at point A is Q and charge at point B is Q naught. See, we are taking here Q naught because it is a test charge. Okay, now what will be the electrostatic potential difference? It is the work done in moving this test charge from point B to point A. Okay, you can take any path. Okay, it does not matter, you can take straight line also. Okay, so work done in moving the test charge from point B to A per unit test charge. Okay, so work done in moving the test charge from B to A, okay, per unit test charge Q naught, or you can write this work done like this also, W from where? B to A, nah? So B to A, okay. So the definition of electrostatic potential difference is work done in moving the test charge from point B to A per unit test charge, okay. So this is the potential difference definition, okay. You can find the definition in textbook also, okay. From there you just copy it, okay. Now, so from this definition, how we are going to define electrostatic potential at any point? Electrostatic potential at any point, okay. Or let's say at point A, okay, here at point A. Just take the example of this one, okay, at point A. So in order to find electrostatic potential at point A, if this VB is 0, then we can easily find, right, VA equal to this one, nah? So we are interested in finding this potential, nah? So we have to make this VB 0, okay. Now in physics, potential at infinity is 0, okay. In physics, we assume that potential at infinity is 0, okay. This point, you have to remember this point, okay. Now with using this point, we will find what is electrostatic potential at point A. So in order to make this VB 0, what we have to do? We have to make this VB, what is VB? VB is this one, nah? That means this charge should be, we have to place this charge at infinity, okay. That means at very large distance, infinity, okay. So if we make this VB, this one infinity, nah? So this point B is at infinity, okay. I will just use infinity, okay. So Q naught. Now, so that means this potential is now potential of infinity, nah? Now, so the work done will be from infinity to point A, nah? So not from B to A, okay. Now it will be from infinity to A, okay, per unit test charge. Test charge is same, nah? So in physics, we assume that potential at infinity is 0. So this term is 0. Now, so it will become like this, VA minus 0, na, potential is 0, equal to W infinity to A Q naught, or VA equal to W infinity A by Q naught. So this is potential at point A, okay. Now we can find, using this formula, we can find potential at any point, okay, nah? Okay, next is okay, we will derive what is electrostatic potential at any point, okay. Now next is derivation of this one. So you remember this formula, okay, VA equal to W infinity to A Q naught, okay. So we can define what is electrostatic potential. Definition will be electrostatic potential at any point, or okay, this example, okay, at, instead of any point you write at point A is equal to work done in bringing in bringing what? In bringing the test charge, right? In bringing the test charge from where? From infinity to point A. From infinity to point A. Nah? From infinity to point A per unit test charge. Okay, test charge per unit test charge. Nah? This will be the definition of electrostatic potential at point A. Okay, so what will be the unit of electrostatic potential? See, from here you can find the unit. You know what is the unit of work? Work is joules, right? Joules divided by what is the unit of charge? It's coulomb. So the unit of electrostatic potential is joules per coulomb, or sometimes we write volt. Okay, unit of potential is volt or joules per coulomb. So there are two units. Okay, now next is derivation of electrostatic potential. So now we'll do the derivation of electrostatic potential at any point. Okay, so let's consider a charge Q at O. Okay, now we have to find electrostatic potential at point say P. Okay, here, so we have to find here the potential, okay, due to this charge. So this is point P and this is point O. So in order to find electrostatic potential, we need what? A test charge, right? So we have seen that according to the definition, that electrostatic potential V A at point. Now this point is this one, okay, is what? Work from infinity to point A divided by test charge. So that means we have to place this test charge at infinity. Okay, so let's say this is infinity, this point is infinity. Okay, so we have to place Q naught here, Q naught, and we have to bring this Q naught to this point. Okay, this P. The distance from O to P is R. Okay, now we have to move this charge Q naught, okay, here in this side, and we have to keep here. Since this is a positive charge, so the electric field lines will be in this direction. So, and this is also positive, so it will repel. Okay, so we have to work against the electrostatic force. Okay, force is in this direction, and we have to bring this Q naught against the force. So we have to move it forcefully. Okay, let's take any point N. Okay, N. So we bring this charge here, and see the force, this due to this positive charge, the force will be in this direction. So this is force, and we have to bring this charge against this force. Okay, let's say here you have to take a small distance. Okay, let's say this is dx, so this displacement is in this direction, and this force is in this direction. Okay, and let's say this point N is at a distance of N. Okay, this is the middle one, so at a distance of x from this point O. Okay, so our aim is to bring this force or this charge to this point. Okay, now let's consider a small displacement dx. Okay, dx means this small displacement, this is very small. Okay, dx na, at a distance of x, okay, from this charge. So in order to find this total work, okay, from here to here, this small distance will have small work done. Okay, and we have to add up all the small work done, okay. That's why we consider a point where we will have a small displacement na. So this is dx, 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 dx. If you take here also dx, dx, dx na, if you combine all these, then we will get the total work. Okay, total work done. In physics, we do it by using integration na, integration. So what is since this is a small displacement dx, okay, this is dx, dx is displacement na, from n to this small length, okay, from here. Okay, so this is very small, dx is very small. That's why, see, if x to this point, or from O to this point is x, from O to this point is also x. Okay, because this is very small na, so it does not matter. Okay, so now here, due to this displacement, there will be a small work done. Okay, because the displacement is small, so work done will be small. Okay, what is the definition of work? Work is what? Force into displacement na, displacement. You have studied in high school, right? So now here, small work done will be dw equal to force dot dx. Okay, dx is displacement, f is force. What is this force? This is electrostatic force. Okay, between this q naught and this q. Okay, so now we will bring this charge to here na, q naught. Okay, this is q naught. We have to bring till here. Okay, q naught should be here na. So now we have bring this one q naught. Okay, here na. So so see, this is a vector quantity. Okay, because it has direction. So force direction is this side and displacement is in this direction na. So they are opposite. Okay, so we have studied in vector na, in class 11. A dot b vector na is equal to ab cos theta, right? And a cross b, vector a cross vector b is ab sin theta. Okay, this is dot product, so we'll use this one. Okay, that means f dot b will be f dx cos theta. Okay, what is theta here? Theta is angle between f and dx na. So what is the angle between f and dx? This one, if I draw here, this is point N, f is in this direction and dx is in this direction, right? So what is the angle? This angle na, it is what? 180 degree na. So this angle is 180 degree na, between dx and f. So what is cos 180 degree? Cos 180 degree is what? Minus 1 na. See, from diagram also you can understand. See, cos graph is like this, right? Cos graph na. So this is 0 angle, this is 90 degree, 90, and this one is 180 degree. Okay, and this one is what? 360 degree. 180 plus 90 is 80, 90, 100, 140 na. 180 plus 90 is what? 180 plus 90, 0, 80, 16, 17. So this is, this point should be 170 degree na. So this is plus 1 and this side is minus 1, this point, okay, this point plus 1 and this point is minus 1. So 180 is this one, 180 is minus 1. So cos 180 degree is minus 1. So cos 180 degree is minus 1, that means f minus dx, cos 180, okay, you write like this, fx cos 180 degree, because theta is 180 degree. So 180 is minus, if you put minus, then you will get minus f dx. So this is small work done, okay, f dx. So make this equation 1. Okay, now what is force? This force is what? Electrostatic force. We have already studied what is force. F equal to 1 by 4 pi E naught Q1 Q2 by R square. So distance, this R is distance between Q1 and Q2. Okay, now here in this case, what is F? This F will be how much? So F will be 1 by 4 pi E naught Q1 will be Q, Q into Q2 will be Q naught, okay, Q naught by R. R square means distance, so what is the distance between this Q and Q naught? Q is here and Q naught is here, so it is x, right? So it is x square, using this formula. So we are getting this F here. So make this equation 2. Now put this F value in equation 1. So you will get, okay, I will wrap this one. So dW equal to minus F. F is this one, 1 by 4 pi E naught Q naught x square dx, dx. So we are getting this one, Now this is small work done, So in order to get the total work done, in physics what we used to do, we used to integrate, right? In class 11 also we have done, right? So if you integrate this small work done from 0 to W, okay, dW. Now here also we have to integrate, but integration is with respect to dx, okay. So all the constant sums should come outside, that is Q naught and 4 pi E naught will come outside, and then we have 1 by x square dx. Now integration should be from where? From infinity to at this point, So this point is what? What is this distance? It is x, right? X, so that is from infinity to x, okay. So from infinity to x, now if you integrate this one, so dw integration will be w only, right? W integration is from 0 to w, 0 to w. So q, or here it is minus, minus is there. Q naught by 4 pi E naught. What is in this? We can write like this also. 1 by x square is x to the power minus 2, dx. What is integration of x to the power n? Dx. It is what? X to the power n plus 1 divided by n plus 1, this one. Okay, this is the formula for integration. You have studied in class 11 also. In maths also you have studied. So now we have to integrate this one. So I'm writing here, okay, q naught from infinity to x. So using this formula, okay, we'll integrate this one. So using this formula, so you will get x, n is here minus 2, so using this formula, x is x, n value is minus 2 plus 1, plus 1, downside also minus 2 plus 1. So it is from infinity to x. So dw integration will be okay, dw integration you will get w, right, w0 to w, so here x to the power minus 2 plus 1 is minus 1, so you get minus x to the power minus 1, and here also minus 1, infinity to x. Okay, this minus 1 is constant, we can take outside, so if you take outside, then minus and this minus will cancel, so you will get x naught by 4 pi e naught, okay, 4 pi e naught, and then we have x to the power minus 1, x to the power minus 1, okay, I don't have space here, x to the power minus 1 from infinity to x. Okay, now here, see, first place you have to first initial or final minus initial, okay, so in place of w you have to put this w minus, now in place of w you have to put 0, this one do you already know, right? Now next will be, next step is so next step, w minus 0 is w, w q naught by 4 pi e naught, 4 pi e naught. Now here also first we have to keep this, right, in place of x, after that this one, so it is in place of x we put this x, so it is same, x to the minus 1 minus is from formula, right? Now in place of x you have to put infinity, so infinity minus 1, so q naught by 4 pi e naught, this x to the power minus 1 you can write 1 by x, right, minus x to the power infinity 1 by infinity, so what is 1 by infinity? W q naught 4 pi e naught 1 by x. 1 by infinity is 0. Anything divided by infinity is 0. Okay, now we are getting the total work done. Okay, so according to definition of electrostatic potential, what is electrostatic potential? We have already studied it. For electrostatic potential V, okay, V is defined as work done divided by charge, work done from infinity to that point, okay, point, here the point is P, so electrostatic potential P. Okay, this is the formula, right? So now what is this? This is the work done from infinity to that point, nah? So that you can write like this also, infinity to that point. If you don't write also, it's okay, we understood. So now work done is this one, nah? So q naught by 4 pi e naught 1 by x, this one, right, divided by q naught, nah? So divided by q naught. Okay, q naught. So this q naught and this q naught will cancel. So v is what? Q naught is already cancelled, right? So 1 by 4 pi e naught q by x, nah? So this is the electrostatic potential, okay, at any point. Now here the point is at P. Okay, so for today over. Okay, for today class I will give some classwork and homework. Okay, you have to do and submit me. Okay, bye.